Thank you for attending IDEX Solutions Lunchtime e-Seminar Series. My name is Taban Thompson. I'm an account manager with IDEX. I'll be your moderator today. At any point during this call, should you need to place your phone on mute, you can do so by pressing *6. So again, the mute function is *6, and to unmute, #6. The 2009 Summer Webinar Series is an 8-part series. This is about the 5th delivery that we've made here this summer. Each time our purpose is to just educate you and do our part in giving you more exposure into useful tips and tricks and functionality that's available in CATIA and V5 and other solutions from Dassault. Today, or actually, if we want to skip to the next slide, I'll tell you real quickly a little bit about IDEX. We were founded in '96. We support all of Dassault's family of products, including CATIA, Novia, 3D Via, Delmia. On the services side, we specialize in PLM implementations, product customization, process development. We have very strong caliber of people for CATIA automation, and we also do some on-site and off-site design services, as well as provide engineering staffing. Today our topic is designing complex molds real quickly and easily with V5. Your presenter today will be Mike Ray of Dassault Systems. Mike comes to us from Dassault. He's been there for 5 years. He's also worked at Ford for a number of years as a vehicle architect. He spent 10 years at PTC as a consultant, including support of a wide range of customers in various industries, a lot of which with tooling design experience. Mike also has a bachelor's in mechanical engineering and a master's in space robotics. So no further ado, I'll turn it over to Mike.
Okay. Thank you very much, Taban. Going to jump right into this. We're going to talk a little bit today about CATIA and the tools that we offer as far as working with inside of the tooling area. And today we're going to focus on mold tooling, but a lot of these tools will actually apply to all areas of tooling design. Quickly, we're going to go through an AVI quickly just to so you can give an overview of what it's capable of doing from end-to-end tooling solution. And then we'll drop into a very, very quick PowerPoint presentation, maybe 5-10 minutes, to talk about the process and how we've gone forward with this and some of the successes we've had with this with customers. And then at the end of it, I will give you a very quick live demonstration of how easy the tool is to use and how we would set it up in the process that we'll go through. So I'm just going to switch over to a video. I don't know if you guys can see this or not. Can everybody see it okay? I'm going to hit the play button.
Yeah, it's good.
Okay, perfect. So this started out as a couple of years ago as an initiative for automotive suppliers specifically who are focusing on tooling design, and has grown quite a lot in the last couple of years. I'll have to be honest, when it first came out, in R12, I think if you were focused on mold tooling, it still had a lot to be desired. By the time R16 came along, we were very competitive, and today we're at R19, and we have no problems offering the best solution within the market for people who are doing tooling design, especially when a lot of their customers are supplying CATIA data. Now, in this case here, we're going to start off with a simple IGES file. It's actually dumb surface data that was brought in. With this workbench, we have a special offering for mold tooling design right now with special pricing and everything that goes along with it. But it gives you access to a lot of power within inside of CATIA, including access to all the surfacing I wouldn't say all the surfacing, 95% of the high-end surfacing capabilities with the CATIA, and also template design, knowledge capture, along with the ability to generate molds and tools very quickly. So in this case here, it also includes something called the healing assistant, which allows you to come in and take surfaces from parts, from step files, IGES files, doesn't matter, and quickly heal these surfaces and turn them into a solid. So that's what that tool was. There's also an option that's included, something called Realistic Shape Optimizer. And what this tool will do is it will take into the deformation of your parts. So in this case here, when we go to cool this plastic part, it's going to deform and it's going to shrink, not in a unilateral method. It's going to have different shrinkages in different directions. So based off of this criteria, we have a tool called RSO, which is called Realistic Shape Optimizer, that allows you to quickly go in, run the analysis, and take that information from the analysis and bring it back to the part. So in essence, what you're going to do is you're going to change the part, you're going to morph the part. So when that changed part is going to be used. So it's going to look like the wrong part, but when it comes out of the tool, it's going to be the right part. We do the same thing with spring back from stampings and so on. So instead of having to figure out how the stamping process is going to work, we're able to run this tool in order to morph this part. Very, very, very powerful tool in generating this. Once I've done that, in this case here, I have to define my parting lines and my split lines. What we're looking here at is very quickly and easily I can define where my parting lines are going to be. We have something called a quick split now that will automatically go through and split the surfaces. In this case here, I'm defining multiple pulling directions, so I'm going to have a slider with inside of this direction as well. So I can define multiple pulling directions and split my surface and my part up into these different parts. So in this case here, I've got a core cavity surface and I've got a surface, a slider surface as well. After I've got these surfaces split, I have my splitting lines. I can generate a parting line. And so this is where it comes in. I have access to some very high-end surfacing tools to create these surfaces, these parting surfaces. By just selecting a few curves, I can actually generate and create the whole surface. Now, based off of all that information, so now I've got my part, I've got my core surface, my parting surface, my slider pulling direction. What I'm going to do is I'm actually going to go in and I'm going to measure this part. I'm going to decide, based off the size of this part, what mold I'm going to use. We have a catalog of mold templates already set up. Pretty well every manufacturer has been defined in our catalog. We find a lot of times, though, that customers have their own requirements, but because the catalog is so robust, it's very easy to add your own components with inside the catalog. It's just a matter of modifying an Excel spreadsheet, and you can generate your own catalogs very quickly and easily. So in this case here, we've got a simple template that's got 2 inserts within it, and based off the size, you know, in this case here, we're calling it a small size, and we're going to use 2 inserts with inside of this. Just speed this up here. So when it loads in this mold base, it's actually loading in all the models for it. It's creating these new models. We're going to actually use the size of the bounding box for this part to define the size of our inserts and the size of our mold. And then we can have it go search the catalog for the right size. If it can't find a size that fits into our criteria, we can have it automatically build one and then add it to the catalog. But typically, most people like to take something that's standard because it's cheaper. We're in the process of including information, you know, based off of the type of mold that you're going to be building, type of, whether it's plastic injection molding or whatever you're going to be doing, and then, you know, whatever the tonnage is and everything else. So we can actually go through all that process of defining the tooling so we pick the right one. So in this case here, we picked this first template. It also will generate all the drawings and manufacturing information along with it as well at the same time. So I picked my tool base. I picked my inserts. It's very, very simple to do. I'm going to show you this as I go through the demo. You basically pick your parting surfaces and you right-click on your parting surface and say Split Component, and it will automatically go in and split your components. In this case here, we set in injector pins. That was pretty fast. Let me pull this back here. So from the ejector pin definition, all I have to do is either pick points on the screen, or I can pick a sketch and we'll drop the ejector pins automatically for me. We even have rules set up so we'll pick the right location for the ejector pins and how many you should use, whether you should be using lifters or whatever your company standards may be, we can capture all that information. So it will also trim back these injector pins. We also have anti-rotation inside the ejector pins. Now I'm going to insert another component. In this case here, I'm going to insert a slider for the pulling direction. So I just pick a point, it drops a slider in. It not only drops a slider in from a standpoint, but also cuts out all the clearance that I need with inside my blocks, with inside my plates, and puts in my holes for me, and the information, the technological results that go with those holes, so how they should be manufactured and so on. So now it'll drop that information and I can take a look at it and I can go take it downstream and use it within manufacturing. So all this information is, because it's inside of CATIA, is all associative. So it automatically will generate my drawings and the different views. I might have to go in and move the balloons because they might not show up exactly where I want them to show up. So it's legible, but it's very simple to do in a couple of minutes. Then I can also take that same information, and because it's tied into my tooling programs, I can actually have it come in. Typically, we do the rough tooling very well. When you get into the finishing, then you're going to want to take some time and verify it, make sure everything is kosher. We can also even look at going through the process and doing full machine simulation to make sure that we have the right clearances and everything else along the way. So all this is within inside of here, and we can even bring in files if you want, and based off of those holes that it goes and finds, we can define different processes on those holes. So whether they're going to be tapped or how they're going to be done, they're bored holes or what. So we have the process of defining all that up front. So as you go through this process and build these templates, it automatically generates your tooling for you. From a prismatic standpoint, it's very, very easy to do, and very little interaction is required. It's just more of a check that's required more than anything. When we get into the surface machining, it still will get you probably 80–85% of the way there. And the rest of it you will go and define and maybe change the pass a little bit and play with the program a little bit. But from a prismatic standpoint, you can define what your behaviors and rules are and set those up front. It will take into account whatever strategies you want to use, from a machining operation standpoint as well. And I think we're going to talk more in this series onwards about machining operations and the capability of it. So in this case here, I'm doing a full machining simulation on the same part, so I can see if I'm going to have issues with my tooling, I'm going to have clashes or not. So that's typically it for an end-to-end process with inside of mold tooling. And as I go into CATIA, you'll see we'll go through the process, and I'll show you how easy it is and how quickly somebody can pick up the solution. And in the past, people have used CATIA from a knowledgeware standpoint to build their own templates and to fit their specific needs. What molded tooling has done is it's captured a lot of the generic behaviors that customers were looking for and customers looking to build, and templates, generic templates. So it gives you a very, very strong starting point and gives you all these behaviors that works with inside the tool that typically high-end users have to do themselves. So it allows you to do a design in context in a top-down design methodology without having any knowledge or idea what that really means. So it gives very base users high-end capabilities very easily. So we're finding the tooling is obviously goes across all industries, and it's an extremely competitive global market right now. However, we're seeing a lot of our customers who were losing work overseas is starting to come back to them, and part of it is because of this package and this offering. I've got customers here in Detroit, believe it or not, who are actually ramping up and getting busier. They're still in the automotive and they're still moved to other areas, but what we're seeing is a trend because the automakers they might be making less number of vehicles, but they're still making the same number of models in some regards, and they're refreshing those models much more often. So every year now they have to have a new front fascia on the vehicle, and it's allowing for opportunities inside the tooling industry. So they're doing a lot more refreshes in that regard, but they're also finding that they're able to expand it, and because they can reduce their lead times for their customers, they'll actually be able to get the quote back and get the tooling back before China's getting the quote back, and that offers them a lot of value, especially when they don't want to pay for the tooling until the last minute, and they want to wait as long as possible because they want to avoid changes. So these are just some of the areas that we were focusing on: die casting, forging die, plastic molding, stamping, progressive dies, jigs and fixtures. Very, very high level of behaviors and that can go on. These are just some of the things that we've done: oil pans, pumps, golf clubs, connecting rods, phones. We've sheet metal for computers, for cars. It doesn't matter. Progressive dies, a lot of it in the aerospace and the automotive and even the consumer goods. And the tooling fixtures, basically all industries. All these are very, very capable. So what we've done, instead of actually building just a tool that allows you to build CAD models, what we've done is we've looked at the process and how people work, and we've offered a process, a focus on we want to be process-centric instead of design-centric. And what we mean by that is just the CAD models add very little value. It's what you do with those CAD models afterwards, the analysis, the machining, whether it's visualizations or clearance, kinematics, all that stuff is where the value is in the CAD model. If it's just a pretty picture on the screen, it really doesn't mean much to me. So we want to make sure we can focus on meeting those needs. We're also looking on the different areas and the complexity that each group has. I mean, they share a lot of things in common, but there's a lot of things that are very different, from doing rubber molding to stampings. However, they have the same methodologies in some regards, but we want to be able to fit those needs. So what we're seeing from trends is everybody is demanding quicker products to the market. They want to reduce costs, obviously, and they want to increase quality. So we're focusing on allowing that to happen. So we've looked at the entire tooling process, going from request for pricing. So we have the ability to do very accurate quotes up front, do preliminary designs, plan the process, everything focusing on that. So we can actually take a part. So I can have an OEM give me a part. It doesn't even have to be a completed part, just a basic idea for the part, so we can start determining the number of lifters or sliders or whatever we need within inside of the tooling for this, and we can actually generate the tooling, a preliminary design within a half a day to a day. From that information, we can then generate a pretty accurate quote, and typically we start building the design for the tooling right then and there at that time, as soon as the quote has gone back to the customer. Because very quickly, once we've got that designed, once we get the final surface from the customer, all it is a replace command. And when we do that replace command on that surface, so we have kind of like a preliminary surface. Once we replace that preliminary surface, we can quickly generate the final tooling from it. So it's a very, very easy process. So once again, we focused on the stages: the bidding, the design, the detailed design, and then the manufacturing. And we've taken it from a series process to a parallel process. So you can actually start working on the manufacturing before I have the finished completed tool. So I'm just going to whiz through these slides very, very quickly so we can get into the actual CATIA demonstration and talk about it. But these are just the different areas, the mold tooling. So we've gone from how do we move customers to the solution. We've gone from helping them take building blocks that we already have within our library, including knowledge and behaviors, and build a very specific tool for the customer, so a generative tool. So I have customers that, based on the customer that they get their information from. So Chrysler has different requirements than Ford, than Honda, than Toyota, than GM. So they actually have different start points and different templates that meet those requirements for each one of their customers. So if they get a quote in from a request for quote from Chrysler, they go and pick this template and they start heading down that process. And what it will do is it will generate the bidding for them and all the documentation along with it. Then based off of that, whether it's accepted or not, it goes through the process of we actually start building the tooling to their specs and their needs. So we've taken the building blocks and moved it into this generative tool, so they now very quickly and easily can build a tool that will fit their needs. We focus on all the different areas from stamping to mold design. I've talked about this a little bit. So RFQ is very, very important to us. We want to make sure we get a good quality quote back. We want to make sure when we do the detailed part that we were very accurate when we quoted. And we want to be able to make sure that everything fits at the end, that the tooling works. So I don't want to have to go back and modify the tooling constantly to make sure the part I get out is the correct part, is the part that the OEM wants or that the customer wants. And that allows me to go into detailed design. We also have the ability to do electrode design within inside of this. We have a partnership with Senate to do die sinking, but we also have an integrated electrode methodology within inside our tool. It depends on the complexity that you want to get into when you're talking about electrodes, which one we would recommend. And then we also have quality control and tooling tryout. And if you do all your GD&T and all your tolerancing within inside of CATIA, you have the ability to actually use that information not only within inside your drawings, but within your inspection tools. Pretty well every CMM customer out there uses an integration with us, and we'll take the information from CATIA and use it within inside the inspection process. And also along this process here, so when you get into stamping, you want to make sure the quality of the stamping is very, very good. Within inside this offering that we offer, you have the ability to do high-end surfacing and high-end surface quality checking. That means I can check to make sure the quality of the surface that I get from my stamping is going to meet their needs. We also partner with a lot of companies such as AutoForm, ESI, Forming Technologies on the behaviors from a stamping process and thinning and spring back information. All that can be done and integrated right within inside of our solutions and inside of CATIA. So it gives you the ability to do a very, very accurate, detailed design phase in the style when you're doing stampings. Progressive dies, I'm going to show you how we go through the process. We have a couple of solutions. It depends on where your solutions fit. that we recommend, but we're very, very strong partnership with customers who are doing this, and businesses such as Forming Technologies and AutoForm and PanStamp, in developing the right tool. So at the end of the day, my CAD model will meet what I'm going to do in the physical world, and it's going to be what I want. So we can do strip layouts and everything else, and define how the stations go, and get into very, very advanced stuff. So we have a lot of customers who have moved down this path and have taken advantage of it. So I'm just going to give you a quick introduction inside of CATIA. Just bear with me here for 2 seconds. I've got to go change the settings on my my screen, my advanced settings here. Troubleshooting. Let me share CATIA with everybody here. Can you guys see CATIA on the screen okay?
Yeah, we got it.
Okay. Yes, we got it.
Perfect. So we're going to jump into CATIA and the different workbenches that come along with this MTE package and what it's capable of doing. So under mechanical design, what comes along with this, you're going to get access to part design and assembly design. It's part of the standard package. But also with inside of here, there's a workbench called mold tooling design, and that's the workbench I'm in. And basically, it's a product workbench. And along the side, you get your series of icons. If you do the insert, you get access to different components. So I can start with from a new mold base, components, guiding components. So we're going to just kind of walk through the process. So just like everything else with inside of CATIA, if I don't know what to do first, if I take a look at the icons in the sign, they're set up in a process for me to follow along. So the very first one, I'm going to create a new mold. So I click on that icon. What this will do is open up a nice little window for me. And inside this window, I have access to picking and adding different plates. So if I want a clamping plate on there, I can click. If I want an upper bar, I can turn these off and on. Let's leave the clamping plate on there. We can leave everything on there. If I want to change the size of it, I have access to the length, so I can stretch it. I can make it wider as well. I can define what the overhang are. I can define what my ejector plate sizes and widths should be. So I can change the thickness of them as well. So I have access to change the size of these components quite easily just by dragging things here. If I want to change the ejector width, here I can make the width a little bit larger. Very, very simple. And then I can actually hit the OK button. What this will do is now it's going to actually go generate these components. It's going to build a product in the tree for me with these plates in it. So in this case here's my product that is created. So it's created my injection side. This is going to be the side that has my cavity, my clamping plate, cavity support plate, and the cavity plate are in here. I also have access to the ejection side, which is going to be the core side. And then I also have the ejector system. This is where my ejector pins and everything else are going to go in here. So that's one way to go, is so I can start from scratch and start going through this process. Or I'm going to go back to let's create a new product here. I can also go into this, instead of actually building one from scratch, which is very easy to do, and this is typically where we start for our templates from, I can go into an existing catalog. So if I click on the catalog icon, that's going to take me into the catalog for mold bases, and I have access to pretty well every manufacturer of mold bases out there. So I have DME, Futaba, Hasco. I see a lot of DME more than anything. If I double click on it, I can break it down into the different series that are available to me. I can actually then go pick the different sizes I want or which mold base I want. I can add to these mold bases very quickly and easily just by going into an Excel spreadsheet. What this does is automatically sizes everything for me, drops it on the screen, picks the right plates and everything else. So I'm going to hit OK. And so now it drops it in. And also at the same time, I can have it drop in with points and information. So I can have points defined where I want to drop in my leader pins, my bushings, whatever I want to have available within inside of these components. So that I have the exact same thing. I have the ejection side. I have the clamping plate, the cavity plate. So very similar to what I had before. I still have access if I want to edit and make changes to this. I can right-click on it and say Edit Mold, and it'll pop up that mold for me, and I have access to that information. So very easily I can generate these plates, generate the sizes. If I want to add additional plates, I can click on Add Mold Plate, and it gives me a list of all the different mold plates that I can add, and so on. And it filters it so it won't allow me to do anything really stupid. It's not idiot-proof, but it's close. It gets you there down the process. I can add a slider within inside of here, and we'll go through that process in a second. If you notice also that it will also create something called a molded part. This is the part that's going to have the core surface and the cavity surface that is linked to it. I can actually start with the molded part. So if I have a product that actually has the molded part in it, it will not create that file for me. It will automatically use the molded part that I have in there. And then I can access the core and cavity in those surfaces, and we'll go through that process in a second. So the next thing I want to do is I want to add some leader pins. So I click on the leader pin icon. And I get this nice little dialog box that pops up. And within inside this dialog box, the first one is positioning. And so what I want to do is I want to actually define where I want this to go. So I'm going to pick this point right here. And when I pick that point, because it's a part of a sketch, it grabs all the points that are tied with it. Then I want to start, where do I want to drill from? What are the plates that I want to cut? So I can pick actually the plates I want to cut. So in this case here, I can actually pick it right from the screen, or I can go right into the tree. So it doesn't matter. So in this case here, pick the clamping plate for the plate I want to cut. And I can define where I want to cut to. In this case here, I can pick down here, core support place. Now based off of those sizes, when I go into my catalog, so I'm going to just browse to my catalog. I'm going to use DME America again. I can pick what leader pins I want. You'll notice that I don't have anything within inside my tree here. And the reason is because where I pick drill from to is filtering my tree. So I get this automatic filter. So it's looking for the depth of those leader pins to be a certain value. If it can't find it, it filters it for me. If I don't like that, I can just remove that filter. And I can get a list of all the ones I want to take a look at. So maybe this is the one I want to use right here. I double click. What it will do is it will drop in the leader pins for me. So the orientation is the wrong way. So I can either hit the reverse direction button here, and they'll drop those leader pins in for me. And you'll notice that as they go in, they're actually buried within inside the component. So I'm going to show you what happens. If I click on the between, from, and to, it shows me the two things that are going to be crossed. The clamping plate is going to be cut. The core plate is going to be cut as well. And the core cavity support plate is going to be cut. So right here, it tells me the cavity plate and the core plate are going to be cut with these tools. If I don't like where they are, I can actually move them. So I can just drag a point and move them around. It's quite easy. If I want to move them individually, I just turn off the Manage All, and whichever one highlights in red, I can move. Now when I hit the OK button, what it'll do is it pops up a warning telling me I've moved some of them. They're no longer on the point. It'll go through and it will cut into these plates. So let's take this plate here, open this in a new window. I just got to change the settings so you can see it. So here's this plate. I didn't have to go in and put the holes into this plate. I didn't have to define where the holes were. These holes were automatically defined based off of that drill hole. So what it basically did is it took that drill hole, took information from that drill hole and copied it into that product. Copied it through that product into that plate. So it gives me access to it. And not only does it copy that information over, if I take a look at it, I have technological results that are tied to these holes as well. So I can get information about these holes very quickly and easily that can then be used within the manufacturing process downstream. And you can actually pull them up, put them on a drawing, create hole tables, anything else you want with them. So now I have access to those holes. I didn't have to do it. And it goes into each one of those plates as well. So if I pick out the cavity plate here, same thing. And change the view. So you can see it put in the holes into the cavity plate and drops that information. It manages all this information, so I don't have to be aware of what I'm doing. It'll automatically do it for me. So this gives me a lot of power in dropping it. And so the way this works, these components, these leader pins, have a couple of bodies within inside of them. So this is what the leader pin looks like. Everything keeps mobile. So, and within inside of this leader pin, I also have access to another body called drill hole. This drill hole body, just update this, is the information of the area of clearance that I want. So I can define what type of level of clearance I want here with side of this. I can actually generate my own drill holes, no problem. So when I'm doing a user component, we're going to go through that process. I can define my own user component very quickly and easily. It doesn't have to be just a part. It could actually be a product. And I can define what the clearances areas are. So all now I have to do is pick a point within inside my mold, drop my user component in, and it will cut through all the plates and everything else and create the right clearances based off of my company standards. And that's all that is very, very easily done. The other nice thing about this is, so when I go back to this product, if I don't like, I got to go hide show that for a second. I'm just going to hide this. So when I go back to my product here, if I don't like one of the leader pins in there, if I don't want that leader pin to be in there, whichever, say this one right here, I can right-click on that leader pin, and I can have an option that says delete component. So when I delete that component, not only does it take out that component, but it automatically removes all the holes and the cutouts with it. Now, typically, if you did this in traditional CATIA modeling, when I dropped in a leader pin, what I would have to do is I'd have to take that body, do a copy-paste specialized result with link into the other part, do a Boolean operation, do a remove on that Boolean on that part, get the hole, and now when I go delete that component, I have to delete the component, then I have to go back and delete the Boolean operation as well. It doesn't seem bad when I've got 4 components, but if I've got like 25 components, so say I have an injector pin, and I'm just going to pick where I want to drop my injector pins on. You can either pick a sketch or just drop them down on points. When I drop in, say, 7 injector pins, it can be time-consuming to go through and want to delete all these injector pins and remove all the holes and everything else that's tied with them. And once again, I can browse through the catalog, pick an injector pin. So now in this case here, I'm going to reverse the direction again of my ejector pins. Go on my ejector plate. I can define what I want to cut from. It's going to go from that ejector plate, and I'm going to go all the way up. In this case here, I just want to cut into the core plate. So sometimes it's easier just to pick it from the tree. So I'm just going to cut to the core plate. Hit OK, and it'll drop in my ejector pins for me. So now it's going through, is loading all those ejector pins, and it's dropping them inside to my parts. And it's only trimming, in this case here, my core plate. It trims up to the core plate. It does not cut into the cavity plate at all. I think I already have it in the window. So it doesn't cut into the cavity plate at all because I did not pick that as my list. So when I go back to this product here, so if I want to edit, say, that leader pin or that ejector pin, so it's under my ejector system. If I want to edit this, right-click on Edit Ejector Pin Component, I have access to what it's going to cut into. And this information right inside of here, this defines what it cuts into and how it cuts into it and the clearance that it has. Well, I don't need it to cut into the cavity plate. So even though the ejector pin at this point in time is going all the way through the cavity plate, it won't cut into it. So with inside my molded part, let's quickly just go build a surface so you can see how this works. So I'm just going to double-click on the molded part. When I double-click on this molded part, you notice the icons on the side of my screen change to the part design workbench. That means I'm actually working on this part within inside the context of the assembly. So in this case here, I'm just going to quickly build a quick surface, nothing excuse me, overly complex, but just a simple surface to represent a core surface. So I'm just going to switch the workbench to the surfacing workbench, GSD, Generative Shape Design. I'm going to click on the extrude icon. I think 1,000, maybe 200 should do it. Take a long F, yeah. Okay. So now I have a surface that's within inside of here. It's gone all the way through. What I'm going to do is I'm actually going to use that surface, and I'm going to say split component. So under my leader pins here, I can go through. I'm just going to right-click on these components. Oh, I got to go back into the mold tooling workbench. So I double-click on the mold again to bring me back into the mold tooling workbench. It doesn't matter if I pick the top product or the mold. Either one will get me there. And I can right-click on this component, and I have the ability to say split component. So I pick the split component. I pick the surface I want to split it with, and it doesn't matter that this surface is in the molded part and doesn't exist within inside the ejector pin. It will automatically take that information. I want to keep the opposite side, so I hit OK, and it will go through and split that ejector pin for me. So let's open that ejector pin in a new window. So now this ejector pin has a split tied to it. You can see it's been cut back now. Here's the information for it. So if I do a hide show, you'll notice that the surface that this ejector pin is taken is much smaller than that entire surface that I have inside that product. So when I have very, very complex surfaces, I don't want to copy the entire surface and bring it over into each one of my components, because I could easily have 100 components that get trimmed. I don't want to have 100 copies of my surface over and over and over again. It chews up a lot of memory, has a large impact on performance. In this case here, it only grabs a little area just beyond what the ejector pin is defining. So it only grabs that little surface area just beyond it, just enough to make sure it gets cut, so I don't have to carry all that information along with me. I only carried a small amount of information. Now I typically would do the same thing. So this would be, say, my core surface. So I would go into my core plate right here, right-click on my core plate, and I'm going to say split component with that. So now I go pick this surface right here, pick the side I want to keep. Say OK. Let's hide show that surface. I don't know if you can see it. Maybe just easier to go look at it itself. I'm going to open up the core plate. It's not open. So here's the core plate that's got that surface that's been split with it. It's got its holes now for the ejector pins that go through it, and it has the holes for these. It also, if you take a look here inside my part, I have information for the technological results, all the information for each one of those holes that can then be used inside the manufacturing process. All these tools are built right, and these behaviors are built right inside of mold tooling. So thus far, outside of that simple surface that I created, I haven't created any geometry. So what it allows me to do is take somebody who's a mold expert, who's a tooling expert, give them access to a library, a template of components that they need, and allow them just to drop these components in and define how they want it to cut and interact with the different components on the screen. They don't have to generate geometry to actually build the mold itself. The same thing goes along with, adding lifter arms and everything else. I'll show you how to do that, how to add gates and runners. It's just a matter of sketching lines. If I want to do cooling lines, I just sketch lines, or even pick 2 points and it will drop in the cooling lines for me. There is an option inside of this as well, where I can add a whole bunch of different components. Like if you right-click on these icons, you get access to all these different components. Under here as well, there's something called a user component, which is this icon down here. What a user component is, it allows me to actually generate my own components that I want to have inside of here. So I can very quickly just create a new part. I'll just do this very quickly here. So I'm just going to have a rectangle on it. I'm just going to turn that into a pad. Hit OK. So now I've got one in there. Now what I'm going to do is I'm actually going to use another sketch. I'm just going to make it a little bit wider. So one of these is going to be my body. So this is actually going to represent my component, the block that's there right now. And this sketch here is going to represent my cutout area for this part. So I'm just going to create a new body. And this new body here, I'm just going to rename it. You call it drill hole. As long as you keep the name drill hole, or let me show you the options here. You keep the name drill hole, pocket, pad, or tap hole, we'll keep the information tied with it. So in this case here, drill hole, tap hole, pad, and pocket are all the bodies that the software is looking for that will automatically do the cutouts. I can actually create my own bodies and link it to another body inside of another part. I don't have time to go into that, but it allows me to get very, very creative on taking information and passing it from one part to another part without having very basic CATIA skills. So now I've got this drill hole, and instead of creating a solid, I'm actually going to create a pocket. So I click on the pocket icon, I pick the sketch I want. I'm going to reverse the direction here. Maybe make it a little bit taller. So this drill hole body, I'm just going to hide show it, is a little bit bigger than this part body. So this is the area that's going to get cut out from the parts. So I'm just going to save this, part 42. So now when I go back to this product, let me go close that window, part 42. So when I go back to this product here and I click on the user component, I can then browse and open up that part I just created. So in this case here, I call it part 42. Click on open. Where I click on the screen, it drops in that part for me. So you can see that it's going to cut down. It's going to cut into that clamping plate. When I hit OK, it goes in and cuts out the clearance for me for that clamping plate automatically. So in essence, all I had to do was, I could have done this as a product instead of just a part. I could make take a whole bunch of these blocks, put them into one product, and do the same thing, drop that product in, and we'll do all the cutouts for every single one of those components. So very quickly and easily can I take information from a part and not only drop it into assembly, but have it clear out the information and make sure the clearances are correct for it. And I can all do this with knowledgeware too, and behaviors and everything else that goes along with it. I just gave you a quick rundown of what it's capable of doing. We didn't really get into a lot of the knowledgeware information. Might as well open up the floor to questions, and if you guys have any.
I'm going to go ahead and automatically unmute everybody, just so you know that's what's going to happen.
Okay. Are there any questions? Anything that somebody wanted to see that we didn't see?
I missed the first part of it, but where are your parts? All the separate components that are in your product.
Where are all the parts?
Yes.
So right now I don't have the only part I have in here is I have one molded part, and all that molded part has in it is one surface right now. So this is the plastic part. It's got, I could brought in anything that has a cavity surface or a core surface. But the actual parts, if you take a look, it builds the product structure for you. So I get an injection side, ejector system. I can actually add my own components. This is like a CATIA product. You can start it off and build your own template and use these behaviors. And then within inside of each one of these sub-products, I have access to the core plate. And the core plate is an actual part. So here's one plate that behaves as a part. I have a riser bar. So if I do center graph, that takes me to the riser bar part. I have a riser bar 2 that's also tied with it. And these are all controlled by a bunch of parameters that are controlled at the top level. So if I go into the mold and I click on Edit Mold, these are all controlled by these values here. And I did this one here from a catalog, so the numbers are blocked off. But if I built one from scratch like I did over here, when I do the Edit Mold, I have access to change, the width of the overall mold or the length of the overall mold. I can shrink it down, and I'll shrink down all the components for me. So I'm controlling everything from the top level, and it's impacting each individual component as it goes down. So it's taken into account top-down design methodology, how they're supposed to interact and interrelate with each other, and the behaviors without having to be an expert with inside of CATIA. So typically this modeling methodology would take somebody who's had, experience with inside of a high-end CAD tool, who's done top-down design, product architecture type of methodologies, to build a template and to run it like this. With mold tooling, we've made it very, very simple. It does all that stuff automatically for you. So the individual components are here. If I wanted to, I actually could have dropped in like a user inserts. I can define number of user inserts and dropped in one user insert and define how that looks as well. So that's what I kind of did with this case here when I dropped that block in there. It's kind of just a representation of what I could do with the user insert. I could have dropped in 5 of them if I wanted to. If you right-click on that, so if I right center the graph on this component here, this user to component, right now it has a U in here, but I can set up and define my own icon for it, so it would have its own component icon. So when I look inside the tree, it looks the right way, so as soon as somebody sees it, they recognize the type of component it is. I also have the ability to say copy the instance of it. So I can actually come down here. I can also replace it and point to another one within inside a catalog. So if I've got a table built, I can replace it with the one in the table very easily. Or I just click on Add New Instance of it. So now it's just going to add a new instance of it, and I just pick where I want to drop them in. So it drops those in for me. What I found is there's a lot of stuff within inside of mold tooling. I've actually started using within inside the assembly design. It's not so much for tooling, but like when I want to drop in bolts with like a product with bolts and washers and everything else, all I want to do is pick a spot, and I want the hole to be there automatically for me. So all I'm doing is now defining points and picking the points, and especially if the points are within a sketch, not only does it drop in the holes, I don't have to use a reused pattern with it. It drops in all the components with it, and along with it, it gives me access to those technological results, which then I can use within the side of the manufacturing process. So I'm actually starting to use this stuff outside of the tooling industry as well. So I guess I'll go back into the to some of the customer stuff, and then we, if there's no questions, we can kind of close it up. So we've had a lot of customers reduce stuff drastically. I have one customer here in the area that purchased the software last June, and we got them going. It took us probably, we did the first project, I think, within 2 weeks after they bought the software, and we had a reduction of about 20%. And it wasn't a tough tool, but it was a very good learning process. At the same time, we did training and helped them capture their knowledge, and they started understanding how KnowledgeWare works and building templates and everything else. From that process, they did a very, very complex tool that had over 13 sliders in it, and I think it had like 10 lifters, a grill for a big truck. So it was one huge plastic, huge tool, so nothing was inside the catalog. Typically, it would have taken them over 600. They would have built out at 600 man hours, and they would have always gone over. The first time they did it in 452 man hours, so they were almost 25% under, and that was the very first one they did. The second one they did in under 100 man hours, and because of it, the OEM is coming back to them with more and more work because of the quality of their tool and the time that they can get the tool and the ease that they can work with them has been spectacular. So they've actually generated more work for their group, and everybody's, you know, with the way the economy is right now, they're quite happy that things are going well for them. And we have tons and tons of customers who've had success. Now, if you're not going to take this to a company that's doing blow molding, because blow molding is very, very simple. You can do that with traditional CATIA very easily, and I wouldn't recommend it. But if you're getting into more complex molds, more complex tooling, it's a very, very powerful tool. So you can see some of the complexity of the tools that we're generating here with inside of it. Even if you're just talking about plastic injection molding, very, very quick. I just visited these guys, DBM Reflex, recently, and to see what they're starting to do with this stuff is absolutely amazing. They've captured a lot of their knowledge with inside of it. So they're now having the ejector pins locate in the right positions, and everything's happening automatically for them. So the idea is a lot of these customers that I'm showing right now, even though things are getting tight and tough for the entire economy, are actually doing okay. You know, not all of them are doing spectacular, but everybody I've come across seems to be doing okay because they've gone down this path. There's a huge opportunity with inside of this industry to bring work back to the United States now. And it just means if we have better quality, better technology, we want to keep that information here and not have it go overseas. All right, Devon, I guess I can give the time back to you unless somebody has some questions.
Yeah, I had a question about your brief coverage of the realistic shape optimizer. Do you have time to expand on that a little bit?
Yep. So realistic shape optimizer is a tool that we use actually a lot with inside the tooling industry, but it expands everywhere. I've used it actually on suspension design. what realistic shape optimizer allows you to do. So when you do run an analysis on a part, so take an upper control arm and from a suspension. From that upper control arm, when I design that part and I put it on the car, it now gets loaded on the car, so it actually bends and it moves into a different position. So now the suspension, so if I design that suspension to behave a certain way, my hard points have automatically moved as soon as I put that upper control on the car. So what I need to do is I need to actually take that upper control arm and design it in a way so that when I put it on the car, it loads and it goes into the right position. And not only when I want it to go in the right position, I want to make sure I have clearances, I don't have clash, and I don't have anything behave wrong with it. So typically, that's been a real challenge in the past to actually design the part wrong and guess how it's going to deform. So that's what Realistic Shape Optimizer does. You take the FEA analysis, it'll take the part, it'll show you how it's going to deform under low conditions, and show you what it's going to look like. I can then actually build my part under low conditions and then take it backwards. So it kind of does a reverse for it. It'll reverse it and it'll take all the information from that part. What it does is it uses an XML file from where all the points were on that part and maps it back. So then it comes in and will take the part and it'll morph the part. So it'll go find a surface point on that part and it'll move it to the right position where it's supposed to be. Then we'll actually run another FEA analysis on it typically to make sure that it bends the right way. So when we get into stamping of components, we can do this as well. So we can run an analysis on how the part deforms. Autoform kind of has their own thing that goes along with it. So does Forming Technologies. All these guys do spring back calculations and everything else. So we can actually take their information and have it deform the surface. So in essence, we take the part, design it the way we want it to look when it's in use, but then we actually take that part from it when it's in use and we go and build the tooling off of it. So we need to change the tooling to account for the spring back or any deformation that might happen during the tooling process.
You don't have
so the RSO is not an FEA tool. It's basically taking the information from the analysis tool and morphing the part back.
So you can start with a dumb solid and still work with your RSO.
Yep.
Okay.
Yep, we do it with step files all the time. STL, it doesn't matter. So you can bring it in. I've sold actually just RSO to customers. They were using another tool, but they needed the capability of RSO, and that's all they wanted. So that's all they purchased was RSO. And we also have the ability with inside of plastics and deformation of plastics and everything else, and to control how it deforms. It's actually very, very accurate. So we did take one customer that was typically when they were doing the stamping process and they were doing it by hand. They would go and stamp it and then test it and do the molding and everything else by a hand process. We took them. They were usually looking at about 20 to 30 tries. They're now down to 1 or 2 tries to get the tool exactly what they want. So huge, huge reduction in time. And then also, skilled labor of guys working on the tool. So they got their money back. I think it was like in the first tool they figured they got their money back. Now they were doing huge tools, so it just depends on the return of investment.
Yeah, you shared some very compelling ROIs in some of those case studies, Mike. Thank you very much. The presentation was extremely valuable. Do we have any more questions? Okay, so just a reminder, soon this video will be available again for replay, so contact your IDEX Solutions representative to help you out, help you obtain information on how to gain the replay. Also next week we'll continue with part 2 of our NC manufacturing enhancements for R19. So make sure that you dial in for that. And as a reminder, if you attend 4 or more sessions with IDEX Solutions E7 series over the summer, you're entered in for a 32 gig Apple iTouch. Thank you very much. Any questions we could take offline as well.
The last slide here has the contact information. If you want to grab my contact information off of there, Tom's, you can grab it from there. As far as the SO goes, our job is not to come in and take money from our customers. Our job is to come in and make our customers more profitable, more viable, and help them generate business and basically form a partnership. at the end of the day, you know, we're not going to stay in business unless our customers are staying in business and are being profitable with our tools. And so, you know, if we have the opportunity, when I work with people, I'm very honest. I'll tell you this is a solution or this isn't the solution, or, you know, we're not going to come in and do a snow job on you guys is basically what I'm saying. I'm from Canada, so I don't know if snow job works in the U.S. or not. All right, thank you very much for your time.
Thank you.
Yeah, thanks, everyone.
Thanks. Thanks, Mike. That was great.
Bye.